Okay guys, so this is going to be an example video of how to go from mass to moles and moles to mass. So the things you're going to need: your calculator, your periodic table, and if you want to write this down, something to write on and with. Okay, so I'm just going to move this to the side a little bit so it's not in my way. So let's start with this first question. And the first question is, how many grams of copper 2 nitrate are in 0.987 moles? Okay, so remember, when we're solving these problems, the first thing we need to do is start with our given and our find. So our given, remember, our given is always a number. So the 0.987 moles will be our given. So 0.987 moles of CuNO3 2 is our given. And our find is how many grams. So we're trying to find grams of the copper 2 nitrate. Okay, so grams CuNO3 2. Okay, so once we do our given and our find, this is where we need to set up some conversions. So remember, you always, always, always start with what you're given. So I'm just going to rewrite, and yes, rewrite. Okay, this is important. I'm going to rewrite my 0.987 moles of my CuNO3 2. Okay, be sure that you include the unit and the compounder element. And then I'm going to draw a dot with a line. Okay, so I'm only going from grams to moles, so I know that this is a one-stepper. Okay, that's from my moldable, from my notes. I know I only need one step to get me where I want to go. So I'm going to put an equal sign. Okay, now we want to eventually end up with grams. Okay, so our conversion factor will either be moles over grams or grams over moles. Well, a little trick. If this is right before your equal sign, your find unit will be the unit before your equal sign. So I know I'm going to have grams of CuNO3 2 because that's where I'm ending, and I will end in this unit. Okay, so obviously we're going to have grams over moles. And another way to check this is that if I put mole of copper 2 nitrate on the bottom here, I have one on the top and one on the bottom, so those will cancel each other out. So yes, I will be left with just grams of the copper 2 nitrate. So now that I've set this up, what number always goes with mole? 1. Okay, so I'm going to plug in 1 mole, and that's for the molar mass. So I need to calculate the molar mass. So I'm going to list out, I have copper, nitrogen, and oxygen, and I have 1 copper, 2 nitrogens, 6 oxygens. So this is where our periodic table comes in handy. So copper's atomic mass is 63.55 grams per mole. Nitrogen is 14.01 grams per mole, and oxygen is 16.00 grams per mole. By now, guys, we should be pros at calculating molar mass. So I'm going to do my calculator. I don't need my calculator for this one. 63.55, 28.02, and it's early, so 6 times 16, 96. I'm going to add these all together. And I got 187.57 grams per mole. So I'm going to plug in my 187.57 grams for every 1 mole of my copper 2 nitrate. Okay, so now that my entire equation is set up, I'm ready to do the math. So how this works. You can imagine that this is over a 1, okay? I don't. I think it's a waste of time. But if it helps you to put an imaginary 1 there, go for it. So everything on the top gets multiplied, everything on the bottom, and then we divide. So as you can see, we're over 1. So anything times 1 divided by 1 is the same thing. So all we have to do is multiply. So we're going to do 0.987 times 187.56. And we should get 185, and we'll go to 2 decimal places, 0.13 grams of CuNO3, 2. And remember to put your answer in a circle or box it in. And there we go. So that's how we go from grams. No, that's how we go from moles to grams. Let's try it the opposite way. Okay. So let me just move this up. So our next question is how many moles of potassium carbonate are in 76.31 grams? Okay, so again, always start with what you're given. Given and find. Given, find. Your given will be a number, so that's going to be our 76.31 grams of K2CO3. And we're trying to find how many moles. So moles of K2CO3. So now we're ready to start. And I'm just going to move this over a little bit so you can see it better. So remember, always, always, always start with what you're given. So I'm going to start with 76.31 grams of K2CO3. This is a one-step conversion, dot and a line, equal sign. Okay, so I want to end in moles of K2CO3. So I'm going to put that here, mole K2CO3. So I'm going to have moles over grams now. So I'm going to have grams of K2CO3 on the bottom. And look, grams on the top, grams on the bottom, they cancel out. Okay? I should have showed you that up here. I'll show it here. Anyways, so what number always goes with mole? 1. So I'm going to put a 1 with my mole of K2CO3. Now that we're here, time to calculate some molar mass. So I'm going to list these out. 213 times 16, 12.01. Potassium is 39.10. And, I'm not doing units on this, but in my final answer, I will. So we have 48, 12.01, 39.10 times 2, 78.20. Add these together. I get 138.21 grams per mole. Okay. So, and you can't see that. Of course you can't. There we go. So that's my molar mass work. So all I need to do now is plug in my 138.21 grams, and I'm good to calculate. So again, you can think of this as being over an imaginary 1. How we do this math: multiply everything on the top, multiply everything on the bottom, then divide. Basically, since these are both 1s, we're taking 76.31 and dividing it by 138.21. So I'll do that here. 76.31 divided by 138.21. And we get 0.55 moles of K2CO3. And I know this is moles because we have a gram on the top, goodbye, gram on the bottom, goodbye, and we're left with this unit. So those were just 2 examples of how we can calculate between mass and moles. Hopefully this helped clear some things up for you. And if you have any questions, you can join the Google Meet or email me.